Hi, a warm wishes to everyone. So, in the previous session, we have seen the importance and necessity of water supply scheme and the various sources of water. So, today we are going to discuss about the types of demand and the computation of quantity of water. So, let us see what is meant by water demand. Water demand is nothing but the amount of water that people are using daily. That is, a person requires so much amount of liters of water per day in order to perform all his activities and household things. So this is known as water demand. So as an engineer, so it is our duty to calculate the amount of water demand and also to calculate the amount of water that is available in the source. So we have to maintain a balance between these two and we have to design a very good water supply scheme. So next, coming to the computation of water demand. So how to calculate the quantity of water that is required for the municipal uses. So the quantity of water can be calculated by multiplying per capita demand into population, so which is given in terms of liters per capita per day. So what is meant by per capita demand? So we all know about population. So coming to the per capita demand, per capita demand is nothing but the annual average amount of daily water required by one person. Okay, so it is nothing but in simple, a person requires so much of liters, for example 100 liters of water a day, so that is known as per capita demand. So it is expressed in liters per capita per day. Okay, so per capita demand is calculated by quantity of water divided by population into 365. So 365, it represents 365 days. So we are calculating the per capita demand for per year. So let us discuss the various factors that are affecting the per capita demand. So the first one is the climatic condition. So in hot and dry climatic condition, the amount of water demand that is required is very high. So we are using water for various purposes such as for gardening, for bathing, etc. So in hotter and dry conditions, so we are consuming large amount of water, so we are in need of large amount of water, so the per capita demand will be high in the hotter regions. And next, coming to the size of the city. So in huge cities, in metropolitan cities, the water demand is really very high. So there the living standards varies. So we are consuming large amount of water. So for sewage system we are taking large amount of water. The people are using flushing system. So these things make the per capita demand very high. Next, coming to the cost of water. So if we fix a particular rate for the water, the consumption will vary. Suppose we are charging for the water, then the water that is consumed by the people is very low when it is given for free. Next one is system of sanitation. So based on the system of sanitation, whether we are using a conventional system or whether we are going for flushing system, so this makes a great difference and it creates a high demand if we use the flushing system. Next, coming to the pressure. So if the pressure distribution is very high, there may be leakages in the pipe and the consumption of water may be high. So the per capita demand will also be high. Then coming to the living standard, high class people always consume large amount of water when compared to the low class people. The middle class people will be consuming a medium amount of water. So the living standard also, it is one of the main factor which influences the per capita demand. Industrial and commercial activities. So industries, some of the industries consume large amount of water. For example, if an industry is producing juices like Slice, 7-Up, Pepsi, etc., they'll be consuming large amount of water. Okay, so the per capita demand for the industry will be very high in such cases. Next, coming the quality. So if you provide a good quality of water, people start consuming more amount of water rather than going for salty water or bore water, etc. Next one is water charging method. So what type of charging method we are fixing? So based on that also the people we started to consuming more amount of water. So next coming to the types of demand. So there are various types of demands. The first one is domestic water demand. Next one is industrial water demand, institutional and commercial water demand, then demand for public uses, fire demand, then water required to compensate losses in waste and thefts. So these are all the various types of water demand. So let us discuss each demand in detail. So coming to the domestic water demand. So domestic water demand is nothing but the water that we are using for the household purpose, such as drinking, bathing, cooking, washing, etc., etc. So this is known as domestic water demand. So as per IS 1172/1963, so under normal condition the domestic consumption of water in India is about 135 liters per day per capita. Okay, so in developed countries, so this per capita may be high, so it may be 350 liters per day per capita. So please mark this IS code. So in this IS code they have mentioned the per capita demand for various water demands. Okay, so keep remembering this IS code. So for environmental engineering, the IS code that you have to refer is IS 1172/1963. Okay, so in this table you can see that the domestic consumption of water. Okay, so for drinking we are consuming 5 liters, for cooking we are consuming 5 liters, for bathing we are consuming 55 liters, for cloth washing we are consuming 20 liters, for utensils washing we are consuming 10 liters, and house washing we are consuming 10 liters. So altogether the per capita demand is 135 liters per day per capita. Okay, so this is a domestic water demand for our country, that is for India. So let us see the difference between the high class and the low class people who are consuming the water. So in this table it is clearly given that the consumption of water of high class people is high when compared to the consumption of water for the low class people. The high class people is consuming 200 liters per capita per day, whereas the low class people they are consuming 135 liters per capita per day. Okay, so the difference you can see that mainly the difference is seen in the bathing, then washing clothes, then washing the utensils, then for lawn watering and gardening is minimum. Okay, so these are all the various differences that you can see, because they are using many machineries, that is many people are using washing machines. Then for washing the vessels they are using a specialized machines. So these makes major difference between the high class people and the low class people. And the high class people they are using the showers and the flushing system. So because of those the water demand is getting increased day by increased. Okay, so this is the difference between the water demand of the high class and the low class people. So the next type of water demand is industrial demand. So the water required in the industries, so it mainly depends upon the type of industry which are existing in the city. Okay, so based on the type of the industry, the consumption of water may become high. So already I have told that if an industry is preparing a juice like sliced fruity etc., they may consume a large amount of water. Okay, and also in the textile industry they will be consuming large amount of water. So this will create a demand in the industry. Then the quantity of water demand for industrial purpose is around 20 to 25% of the total demand of the city. Okay, then the industrial water demand is 40 liters per capita per day. Okay, so this is the per capita demand for the industry. So here you can see that the per capita demand for high scale industrial zones and for small scale industrial zones. For high scale industrial zones, the per capita demand is 450 liters per half per day, whereas for small scale industry, the per capita demand is 50 liters per half per day. Okay, so next coming to the institutional and commercial demand. So you all will be knowing about the institutional and commercial buildings. So the water that is consumed by the institutional buildings and the commercial buildings are known as the institutional and commercial demands. So the various institution that's coming is the various universities, then schools and commercial buildings, commercial complexes, warehouse, stores, hotels, etc. So these are all coming under the institutional and commercial areas. So the water that is consumed by these institution and commercial zones is coming under this category. So in this table you can see that for various commercial and institutional places the per capita demand is listed out here. Okay, so for instance, for nurses homes and medical quarters they are consuming 135 liters per day per capita per day. For hotels they are consuming 135 capita per day. Then for offices they are using 45 per capita per day, etc. The next type of demand is demand for public use. So the quantity of water required for public utility purpose such as for washing, sprinkling for roads, etc. comes under the public demand. So to meet the water demand for public use, the provision of 5% of total consumption is made in the designing of the waterworks for a city. Okay. So in this table you can see that the demand for the public use is 25 liters per capita per day. Okay. So next coming to the fire demand. So fire may take place due to various faulty reasons, if there is any shortage in the electric wires or any short circuiting, fire catching materials is available. If there is any explosion, so fire accidents may take place. So for fire accidents we are consuming certain amount of water, so that is known as a fire demand. So fire demand can be calculated by using this formula, that is the quantity of water is equal to 3182 square root of P. Okay, so where Q is the quantity of the water required in liters per minute, where P is the population of a town or a city in thousands. Okay, so in this table you can see that the fire demand is about 15 liters per capita per day. So out of all the demands, the fire demand is the one which acquires very low water consumption. Okay, so the next type of demand is the demand due to losses and waste. So we are losing a certain amount of water in the losses in the pipes and also in the wastages. Okay, so in the distribution system the pipes may not be connected properly, so due to that reasons there may be some losses. Okay, here I have listed some of the reasons for the losses, that is losses due to defective pipe joints and the cracked and the broken pipes, faulty valves and fittings. Okay, so losses due to the when public people just open the tap, in some places you can be seeing that the public people will be opening the taps and going out. Okay, so in that cases also some amount of water will be getting lost. Okay, so these losses, the water that is spent in these losses comes under the demand for losses and waste. So here in the table you can see that the losses for the waste and thefts accounts for 55 liters per capita per day. Okay, so in municipal water supply system itself, in real time you can be seeing that they'll be having pipe joints, and in some places you can see there will be leakages in some of the pipes. So due to that many water will be losing. So this comes under water demand due to losses and waste. Okay, so let me summarize once again. So today we have seen about what is meant by water demand. Okay, so how to compute the quantity of water. Okay, so the water quantity is calculated by multiplying the population into the per capita demand. So we have seen what is meant by per capita demand. Per capita demand means the amount of water used by a person per day, that is known as per capita demand. Okay, so what are the various factors that is affecting the per capita demand? and what are the different types of water demand, and for each water demand what is the per capita rate for each water demand. Okay, so these are all the things which we have seen today. So let us see a small assessment on today's class. Okay, so the first assessment is the average quantity of water in liters per capita per day required for domestic purpose according to IS code is dash. Okay, so I have given you four options. So one is 100, A option is 100, B is 120, C is 70, and D is 135. So its unit is liters per capita per day. Okay, so tell me what is the answer for this. So we have seen in this class. Yes, so the answer is D, 135 liters per capita per day. Okay, so second question is the average consumption of water required in factories in liters per capita per day is dash. So the first option is 10 to 15, second option is 20 to 30, third option is 30 to 45, fourth option is 70 to 80. So the unit of all these is liters per capita per day. Okay, so tell me what is the answer for this. So how much of water that we are consuming for the factories? Yes, the answer is C. So it is 30 to 45 liters per capita per day. Okay. So the next assessment is, so in which type of water demand minimum average consumption of water takes place? Okay. So the first option is domestic water demand, second option is industrial water demand, third one is institutional and commercial water demand, and fourth one is fire demand. So what will be the answer for this? So as the answer is D. So it is fire demand. So the minimum average water consumption that takes place is fire demand. So it accounts to 1 liters per capita per day, which is very less, but this water is required in very less duration. Okay, so we have seen that totally for fire demand we are just consuming 15 liters per capita per day. So this is the least one that we are consuming it. Okay, so these are all the small MCQ questions. Okay, so here some of the references I have added, so kindly use these references, so it will be very much useful for you. Okay, thank you.